Hello all. Today we are going to cover one of the most important and simple sorting algorithm, that is insertion sort. If we go with the algo, the very first point, as the name specifies, the goal is to insert all the values from the unsorted order into the subarray with sorted order of values. When we start with, we can consider only the first value as the list of sorted values, while all other n-1 values in the array of unsorted values. In the example on the slide, the first value, that is 61, we consider that it is a sorted array of values only with only single value. Rest all 7 values, that is 54 to 39, that is an array of unsorted values. The task according to insertion sort is insert all the values from the unsorted portion into the sorted portion. Now is the turn of 54. When we are inserting 54 into the sorted arrays, we are supposed to compare it with 61. So, as you have a look at the code, the loop which we have implemented, that is from j equal to 2 to n a dot length. Why so? Because for j equal to 1, the value is 61 and that is already sorted. So, we are supposed to insert only the values starting from 54. So, line number 1 says that for j equal to 2 to a dot length, that is j equal to 2, then key comes aj, that is in this example it is 54. Now since we have to insert it into the sorted array of 61 for which j equal to 1, so I equal to j minus 1. Now 54 will be compared with 61. Since 61 is greater than 54 and we have to sort in increasing order, so 61 will be shifted on the second position, that is it will replace 54. Now if you have a look at the code, line number 4th, it says that while you don't reach the leftmost position, that is while you don't reach I equal to 1, and until the term, that is the value of the array, comes out to be greater than the value which we are inserting, that is 54 in this example. What it is supposed to do next, have a look at the line number 5 and 6. Line number 5 will shift the value of 61 to the right hand side. It will replace 54. And what about 54? It has been saved in one of the variables named key. So line number 5 is shifting 61 from the index 1 to the index 2. Since this process has to be continued, so line number 6 will decrement the value of I, that I equal to I minus 1. When it exits from this while loop, then it means we have reached the leftmost position, or either the leftmost position or till the position ai is greater than key. Now if you have a look at the next point, now since I had reached 1, so when it gets on to be 0, it exits the while loop and reaches the line number 7, that is it, since I gets on to be 0, now in this example we have to insert the value of 54 at I equal to 1. So in line number 7, we have said that I plus 1 equal to key. So the value of 54 is saved at A1. Now if we have a look at the next point, what will happen now? When j gets on to be equal to 3, then what is the scenario? It says that the key value comes out to be 47 now. Since the value is 47, which is lying at the index 3, now we have to start the comparison from I equal to 2. Now since I equal to 2, now we will, since key equal to 47 now, since key equal to 47 and the value on the I equal to 2 is 61, so 47 will be compared with 61. Since 47 is less than 61, so 61 will be shifted to the right and 47 has been saved into the variable named key. 61 is shifted to the right, it has overwritten 47. Similarly, on the left is the value of 54. Again 54 will be compared with 47. Then what will be happening? That 54 will again be shifted to the right because it is also greater than 47. Now we have reached the dead end, that is I gets on to be equal to 0 now. When I gets on to be equal to 0, it exits the while loop of line number 4 Now it's when it exits the loop of while loop of line number 4, it reaches the line number 7. And what is line number 7 doing? When I gets on to be equal to 0, line number 7 says that ai plus 1 equal to key. In this example, since I was getting on to be 0, so a1 is equal to key, which was 47 in this case. So 47 has also got inserted into the sorted array of values. Now what is the scenario? 47, 54 and 61. They are in the sorted subportion, and rest of the 5 values are in the unsorted portion. So as per logic of insertion sort, what we will be doing next? Now 83 will be inserted into the sorted portion by comparing it with the order of values 61, 54 and 47. So you can say that in this case, I would say that comparison will continue till it reaches the value when the value gets on to be greater than smaller than 83. Now if we get on to the complexity of insertion sort, what is the scenario? If the value is already sorted, if the values are already sorted, what is going to happen? For example, if we say that in this example the array is 47, 54 and 61, this is the input I say. If I say that the input is 47, 54 and 61, what will be the scenario? 54 will be undergoing only single comparison, that is with 47. Similarly, 61 will also be undergoing only single comparison, that is 54. Why so? Because 54 is getting on to be smaller than 61, so it is automatically granted that the value to the left of 54, that is 47 in this case, that will also be less than 61. So 47 will not be compared with 61 if the values हैं, they are already in the sorted order. So in this case, I say that if insertion sort input is given as already a list of sorted values, only the last n minus 1 values, that is leaving the first one, each of the values will be undergoing only a single comparison. So the total number of comparisons will get on to be how many? N minus 1, assuming that the number of values in the array is n. So the total number of comparisons will get on to be n minus 1 in this case. So the n minus 1, as you know already, that what is the asymptotic notation of n minus 1? It is theta n. So it means best case complexity of insertion sort is theta n. When is this encountered? When the values are already sorted in the desired order. If we want in increasing order, our input is already in increasing order. So n minus 1 value comparisons, theta n time complexity. Now getting on to the worst case. Worst case in insertion sort will be encountered when the order of the values is reverse as the demanded order. For example, that is, if we demand in increasing order and the input is in decreasing order, or vice versa. In this case, what will be the scenario? That the number of comparisons that will be encountered by the second value will be 1, and the number of comparisons that will be encountered by the third value will be 2. In general, nth value will be encountering n minus 1 comparisons. So the total number of comparisons will get on to be how much? 1 plus 2 plus till n minus 1 if the number of values in the array are n. So it is getting on to be AP series. Now as you know that if there are first n values 1 plus 2 plus up to n, the number of the sum of AP series is n into n plus 1 by 2. In n into n plus 1 by 2. In this case, what is the value of n? It is n minus 1. So what will be the sum of this array, this series? It will be n into n minus 1 by 2, that is n square by 2 minus n by 2. Now since this is a quadratic equation, the degree is 2. So what will be the time complexity in this case? It will be theta of n square. So worst case time complexity of insertion sort is theta n square, and this case is encountered when the input is reverse as the desired output. Now getting on to the average case. Average case says that neither it is in neither of the orders. It is neither in the desired order nor it is in the reverse order. It is somewhere in between. It is random. So in this case, average, I say that if the number of comparisons I say that are half those of the ones encountered in the worst case, then what will be the number of comparisons that turn to be? It will be n square by 4 minus n by 4, because those of worst case is n square by 2 and minus n by 2. So in this average case, it will get on to be n square by 4 minus n by 4. Now as you know that this is also one of the quadratic polynomials. So quadratic polynomials as per time complexity as per asymptotic notations. What will be the time complexity in terms of theta? It will be theta of n square. So in the best case scenario, complexity is theta n, and both in worst as well as average case, the complexity of insertion sort is theta of n square. Thank you.